this year as well. Last year I was doing this the first time in Malmö, doing this kind of presentation, chairing this kind of presentation with the first results we had on the MTG at that time, FCI and the LI. That was a very nice presentation. It was in the middle of our commissioning. We are now like at the very end of commissioning, so we will go soon operational. So this is a presentation where we recap some of the things we've done and also explain some of the hiccups we've had, especially the so-called COM anomaly that you have heard maybe done. I just mentioned here in the earlier presentations yesterday, so now you actually will understand what it actually is and what it actually does and how we actually solve that. So I think that's all green now, so nothing to worry. But I think we will have 3 speakers here, so that's James Champion from ESA. Then we have 2 guys from EUMETSAT, Alessandro Burini and Ali Mousivand, who will then, James will start with the technical part, and then our guys will continue with the science part. I think we can just start straight.
Okay, thank you very much, Jochen. Does this work? Yes. So firstly, a few words. My name's James Champion. I'm currently the European Space Agency project manager for Meteorsat 3rd generation. I took over this role, for those of you that don't know me, on the 1st of November last year, so not actually that long. I took over from Paul Blythe, who a lot of you may well remember when he retired. So I'd also like to say that whilst I like talking about MTG, this unfortunately is not one of the topics that I had envisaged ever talking about. So I'd rather not be talking about it, but it's very good to be open and honest and transparent with it all. So that's what I hope you'll get from this presentation today, is a true reflection on where we are. A few more apologies, but certainly to you, the audience, because this presentation is not your typical conference style, colorful animations, videos, wham bam. No, I'm sorry, but this is a bit of PowerPoint engineering slides. This is a lot of text. This is not that eye-catching. And finally, apologies to the chair, Joachim. I know you gave me 10 minutes, but I'm afraid I may overrun. I don't have that many slides, but I'm going to be a bit verbose. Okay, so moving on. So I will talk about just a few things. Can we get this telly on, please? Okay. So we'll talk about the anomaly occurrence, the timeline, the investigation process that we went through, the root cause identification, and then the way forward for in-flight, and then also for the current status for the on-ground satellites and what it means to them as a consequence of this anomaly. So just to put it in context, what happened? So I've got a slide on the timeline a bit later on, where we'll run through it, but effectively about a year and 1 month after launch, so about a year after the whole commissioning process, an anomaly was seen on the FCI, on the Flexible Combined Imager. So we completed the satellite commissioning. It had been handed over successfully to EUMETSAT, and then about a month later, whilst commanding the calibration and obscuration, thank you very much. Whilst commanding the calibration and obscuration mechanism, the COM, from the shutter position, from being closed into the black body position in order to do the calibration activity, the current limiter on the nominal side of the instrument control unit, so, the motor drive board triggered a fault detection and isolation recovery automation and put the FCI back into survival mode. So there was an onboard triggering, something had gone wrong, and we didn't quite know what it was. At that point in time, we only had the nominal telemetry available to us, the nominal telemetry data rate. And so actually, as you'll see on the timeline a bit later on, there was then a few other things to consider, because this was just before the relocation of the satellite from the commissioning orbital slot of a few degrees outside of zero towards the operational slot of 0 degrees. And for that orbital relocation maneuver, we were going to turn off all of the instruments anyway. So the instrument did shut down. It went into the mode ready for the orbital relocation. And then we were analyzing the telemetry and what can we do. So we then prepared the satellite to be put into a high-rate diagnostic mode for this part of the instrument. This was a new feature, more advanced feature when compared to Meteorsat's second generation, to give us an opportunity to observe what would happen when we tried to switch back on the FCI after the orbital relocation, which was then done on the 5th of February. Unfortunately, the anomaly was observed for a second time at that point in time, but as I said, we had the high-rate diagnostic mode running, so we got a lot more data. So the next bullet, as I said, the anomaly occurred after the commissioning, which was after a year and 1 month after launch. To highlight, this failure detection, isolation and recovery automation, on both occasions, the COM itself was driven back into the shutter position. This is to save it, this is a security mode to prevent accidental direct sun impingement. So it's just putting a cover over the front of the optics. And it was driven back into the closed position to safeguard the FCI using the redundant side electronics, thereby proving that the redundant side was fit and healthy. So what is the COM? So this is a picture of COM-I. I'll stress that it's COM-I because a bit later on I'll talk about COM-S, which does a similar feature, does a similar function, has more or less the same electrical schematics, but doesn't look like this. It's a different configuration. So the calibration obscuration mechanism is basically a rotating wheel with a stepper motor that then is driven in order to place these discs that you can see in the bottom right-hand corner into the various locations depending on what kind of calibration it's going to be doing. So the infrared calibration is using this black body, so that's driven into one of these P1 positions, so you can see the rotating axis. And here the black body has a very controlled radiant source in order to help with the infrared calibration. For the V-near calibration, we've got these metallic neutral density discs that are driven into place. They're driven into place about four times a year, so either side of each equinox when we come to do a yaw flip, so a few days or a week or so before and after each equinox, we'll do the V-near calibration, where we scan the light beam from the sun at the north and south poles. So it's not, yes, so it's just a stepper motor. It's a very simple stepper motor that moves these discs that are used for calibration purposes into place. And of course, you can see the free beam position here below the, so here. And this is where it is now, and we'll mention the free beam position a bit later on. So I mentioned the timeline. So here we can see that 13th of December 22, MTG-I1 was launched. I showed a picture of that yesterday in my, in due course. I can see that, yes, so yesterday I showed a picture of the launch of I1, which was all good in the end of December 2022. We then spent a whole year doing the commissioning activities. In fact, the satellite's commissioning results review was run in towards the end of 2023 with EUMETSAT, with the kickoff, steering committee and closeout. This all happened. And then unfortunately, a month later, the anomaly occurred. And as I said, the FCI COM was doing some black body calibration at that time when there was an LCL, a latching current limiter, triggering while commanding the COM into the open position. The repositioning of the orbital slot I mentioned happened in January to February, and then we turned back on the instrument afterwards in February, this time with the high rate diagnostic mode in place, and it was triggered again. So in February 24, we all leapt into action. We agreed an investigative approach between ESA and EUMETSAT. The roles, responsibilities, and apportionment of tasks was well defined and agreed. I've got a line on that on the next slide. And we then just started investigating what was up. It included the definition of some various in-orbit tests to be done on the failed path to help narrow down the affected perimeter. It also then went on, once that had been done, to identify some tests on the redundant path to confirm that it is suitable and fit for purpose. And I was very happy on the 23rd of May that the FCI returned to operation in this free beam position. So there was no more in-instrument calibration possibility. And between then and now, the spacecraft configuration updating is underway in order to maximize the satellite autonomy. In fact, as we'll see on another slide coming up, this has taken it's been chunked into 3 parts. The first one in the short term to look after station keeping maneuvers. Why do I say this? Because for every maneuver that was going to be done, the station keeping maneuvers are done on a periodicity of about 2 to 4 weeks, and we were going to close the comm and put it into the shutter mode in case there was any problem during the orbital station keeping maneuver to prevent any potential consequence of an inadvertent direct sun intrusion. So this had to be overcome for the station keeping maneuvers, and then for the midterm, I mentioned already. No, I haven't mentioned already, but there's a yaw flip that's done at the equinoxes in order to keep the overall satellite, in particular the FCI, in the right thermal control. And again, this is a maneuver that had baselined the operational mode to be with the comm in the shutter position. So we had to manage these. And then on the longer term was to return the satellite into the most autonomous mode possible. So the traditional slide with lots and lots of text, it's just to show you an overview. The middle part in bold, the root cause identification, I summarize on the next slide, so I'm going to skip over that slightly. But as I said, the investigation process organization, this was key to resolving this in the timely manner that has been achieved. So the cooperation and collaboration was key. There's one team. It's one team of ESA, one team of EUMETSAT, one team of industry. So the ESA team was responsible for the detailed technical investigations with the industrial counterparts, and we would then feed that into the EUMETSAT's MRB process in order to ensure that the right technical recommendations were being used to safeguard the operations of the satellite. The priority, of course, was to ensure the safety of MTG I1, with the initial position being that the redundant chain shall only be operated after a space segment recommendation. We knew it worked, we didn't know for how long. Anyway, we then went through the root cause identification process. I'll come into more detail on that in a bit, and which ended up with a way forward, recommendations for I1, assuming the loss of the nominal comm drive electronics chain, would identify measures to reduce the stress and operational time on the redundant comm drive electronics chain, knowing that that's the one that we would be using in the future, increase the robustness of the I1 operations, i.e. limiting the number of possibilities of a second failure, assessing the performance impacts. This is what our EUMETSAT colleagues were very much involved with, and I'm very much looking forward to hearing their presentations after mine. And to explain what's the instrument impact, what's the impact on the performance following this lack of calibration in instrument, so what can be done with vicarious calibration. And then, of course, the way forward for the recurrent satellites. What are we going to do then? So going back to that middle block, what did we do? So this was the generation and evolution of a fishbone analysis. I'm sure that anyone's ever been involved in any hardware anomalies on ground, in flight, whatever, you tend to brainstorm and you come up with a whole host of problems, ideas, and at that point in time, at the beginning, it doesn't matter how silly they are, how ridiculous they are, they need to be put on the table in order to be taken them off the table, in order to be crossed off. So everything was put down. Again, this was a multi-party activity involving many, many people throughout the whole subcontractor chain. It wasn't just ESA doing it, it wasn't just ESA and EUMETSAT doing it, it was throughout the whole subcontractor chain. Everybody came together to help, assist, and work on this issue in order to come to the right conclusion as quickly as possible. So there was an in-depth analysis of the available telemetry. As I said, we did these additional in-orbit tests to get extra telemetry with this high-rate diagnostic mode that we now have. And that helped get a signature of the problem. In parallel, there was a complete and thorough review of the whole electrical design and architecture. All the schematics were analysed in depth. There was a whole series of modelling simulations done by the companies involved in industry, we had independent experts from outside the MTG project in ESA who came in to help us do these simulations, such that we could use other people's experience and expertise in order to come up eventually with a series of injected failures that would recreate the signature. So we found a few ways in which this signature in flight could be reproduced on ground. And of course, a review of the as-designed definition. So this was very important. Was there a mistake in the design? We thoroughly hope not, that after, 12 years before launch, there should not have been any design issue. There'd been a thorough set of design reviews, preliminary, critical design reviews at satellite, instrument and equipment levels. There'd also been a whole series of qualification activities done with dedicated qualification models that I mentioned in the bottom bullet here. This qualification model for the COM-IQM had actually seen 2 whole series of separate qualification test campaigns. Now, this is extraordinary. Normally, we just do one set of qualification campaigns where you expose the equipment to the full set of environmental conditions that it will see in orbit with margin. But we did it twice because this COM has a launch lock device, and we wanted to know that regardless of what happened, if we launched with the launch lock open or closed, it would still function as it was meant to. So it was an extraordinary amount of qualification that had taken place. So we inspected all the on-ground models, everything, all the development hardware, and the other FM models as well, to identify whether extra investigative tests were needed for this. Fortunately, they weren't needed. So as I said, the comparison between the as-designed definition and then the as-built configuration, was there a problem in the build status? So what was actually built, was it the same as what was designed? So this took an awful long time, going through the whole of what we'll find out on the next slide, area of concern. As we were going through this, risk assessment for remaining redundant hardware in orbit and risk assessment for other hardware on ground, this had to be done in parallel, given the need for getting MTG I1 back up on time, and also taking advantage of the analysis being done here on the I1 hardware to see what could be done for the future recurrent ones. I've got to speed up, yeah. Bottom line, the root cause has not been identified and confirmed yet. However, and I missed a bit off this line, there is a short circuit within an area of concern. We've been able to narrow it down to this area of concern, which includes the connectors and internal harness up to the motor coils within the COM I1. There's about 5% of the PCB board within the instrument control electronics that's got about 5 components in there, and then the interconnecting harness. This is the perimeter of concern. This is the smallest we've been able to make it. So after the thorough review of all of these design and build features and simulations within the area of concern, there's been a handful of weak spots that can be considered as being candidates for the location of the root cause, but there is no proof of these actually being the root cause. But there is a short circuit in that area. The way forward for I1 is to reduce the stress and cycling and the operational time of the redundant COM drive electronics chain, because we don't know if there was some wear out issue. We don't know what caused it. It had been operating perfectly fine for just over a year. So everything's being done to minimize any stress on it. Reduction of operating current as well. So it was being operated at 500 milliamps. We've now gone to 300 milliamps, which is still well within the qualified range, but it's less demanding. Reduction of actuations. This has the impact on performance being evaluated by EUMETSAT, which we'll come to in a bit. And increased robustness of the I1 operations that needs to be addressed. So what are these performance impacts? Then we've got what did we also do was defining these short, mid-term, long-term solutions. I mentioned these already. So the short term was the station keeping maneuvers. These have been well mastered since May 24, so we know how to do the station keeping maneuvers while keeping the COM open in free beam position. And the same for the biannual yaw flip maneuver. This was performed earlier in September, last month. And that was performed successfully again in free beam. The way forward for the on-ground spacecraft, so I2, I3, and I4. So we're addressing these weak spots. They've not been proven, but they're within the area of concern. And so we've gone in, we've opened up the hardware, we've gone to those weak spots, we've done any rework where necessary. If there's something that's slightly amiss with the harness routing, it's been improved. And then the recovery is, and then the reintegration, the reassembly, any necessary retests have been performed. And of course, the implementation of any positive operational finding from the I1 operational recovery actions will be put into place. For S1 and S2, as I said before, the same identification of weak spots was done. We've addressed the recommendations coming out of these, out of the I1 anomaly. Particularly for S1, all parts have been cleared as part of this rescreening process. As I said before, there is a completely different configuration for COM-S to COM-I. So where some of the weak spots were seen in the COM-I build, they're not there, they're not present. The configuration naturally does without these areas. So it's not been necessary to do any corrective actions. This has been confirmed. All the other parts of the hardware have been confirmed as well, so the interconnecting harness and the ICU as well. And within the frame of the MTG S1 qualification acceptance review that I mentioned yesterday, we have confirmed the flight readiness of MTG S1 with respect to this anomaly. To conclude, it's been a long journey. It's been quite stressful for a lot of people, but the cooperation and collaboration of the many, many people, the companies and agencies involved, has successfully recovered the unforeseen anomaly that befell MTG I1 FCI after a year of operation. So a huge thanks goes to the EUMETSAT teams, the ESA teams, and of course our industrial teams, who without we wouldn't be able to have recovered the situation. And we now look forward to consolidating the long-term operational configuration of the satellite with EUMETSAT in order to, in the frame of the operational task force. So thank you very much. I'm going to end there, and I'm sure there'll be a few questions.
Thank you, James. I think we'll do all the questions and answers at the end, so yes. We continue straight with the EUMETSAT presentation. So so Alessandro and Ali, you will then switch speakers as you wish.
Okay. Good morning, everybody. Let's recap from where we were last year. So last year I showed you some results from the early commissioning results. And now let's start from November last year. This was the test that we did before the so-called super rapid scan. So we commanded FCI in a special mode of basically staring a look at the same place, trying to mimic what ABI is capable of doing over a selected area. Here FCI is commanded to take basically an image every 40 seconds. So each frame of this image is 40 seconds, 500 meters as a resolution. You will see some steps in the animation because we had to recalibrate the instrument every 10 minutes. Basically, we managed to capture convection and overshooting tops over the Central Africa area. And this was just to demonstrate the capability of the instrument for the next generation. So we wanted to command the satellite, the instruments to prove the technology also for the upcoming generation of the FCI. Then again, some other images from last year, some to demonstrate the capability of the instrument to monitor and to safeguard the properties for the fire detection. This was a fire event in Sicily, Italy. And you can actually see how this blending of true color and fire channels can actually see how the fires are evolving, and all the smoke is then transported by the wind. Another example that we performed during the commissioning is actually the monitoring of fires in using the rapid scanning mode, which is the scanning of a particular area every 2.5 minutes. So you can actually see how more fluids are the evolution of the events, and how the fire is actually captured in its evolution. You might notice some wobbling of the images. This was due to the, let's say, preliminary performances of the processing facility at that time. Now let's jump to this year, this summer. So last summer in August, it's another fire event captured by FCI in Athens. Probably you might have heard about this fire event during the summer. You can actually see how the smoke is detected by FCI, and the fire event is actually captured and transported to the south by the winds. And this is another nice image that we wanted to show you. It's the eruption of Etna in Sicily this year that caused also the closure of the Catania airport. So you can actually see how the event is really well captured by FCI, and this was something that we could not observe so well with so many details with Severi. So it's actually a really step forward for this kind of technology. Again, another application is, let's zoom out. Let's start to look at Europe. Again, it's this summer, so late August. It's the transportation of the smoke from Canada up to Europe. So you see basically the smoke is, oh, okay, you can barely see here. It's on the TV is a lot better. But basically there is this smoke that is coming from Canada, and then is transported over Spain, and then down to Italy, and then over this type of circulating area. Another achievement that I would like to share with you is the so-called geocolor. It's basically a blending of visible infrared channel during day and night time, and it's done in collaboration with our NOAA colleagues. It's developed in the framework of SatPy, so of the PyTroll initiative, and it's open source and available for all the users. So you can actually install the Python packages and recreate with this type of data and animations with FCI data with no effort at all. And we can also provide you with some examples and support. Let's go to another phenomena during this year. This is basically Ukraine. And it's a storm. It's actually a kind of cyclone here, and you can see on the left the so-called FCI true color at 1 kilometer, and on the right it's the cloud face that will give you more information on the type of cloud that you have. You can actually see how from last year, where we started to have only some spots of the FCI images, we went to continuous observations of the phenomena. Here it's a 4 days of acquisition. We can actually start to observe a lot of more phenomena. So we can actually see how the instrument is benefiting the scientific community. Here again, it's another example of over Italy, on how the contrails can be detected and are showing up. Here you go. I hope you see them here. And how FCI is capable of detecting such phenomena thanks to the resolution and also to the spectral to the new spectral bands here. The point is that this type of contrails were not visible in Severi. So here again, it's a demonstration on how the instrument is well performing and well behaving, and also the type of data that can deliver to the scientific community. Another look is the convection over Italy. So you can actually see here Apulia, Sicily, south of Italy, and then a lot of convective cells that are popping out in during the day, and here and here. You can actually see how this type of phenomena are evolving, and how good is the instrument to detect this and to monitor this phenomena. Here it's an example over the Scandinavian region. Here we are using actually a stereographic projection to give the best resolution on this type of latitudes, because when we use the orthographic projection, basically here everything is compressed. But here to demonstrate how good is also the instrument at higher latitudes, how this type of resolution can serve also our delegates from northern countries. And again, when the instrument started to observe every day and in a continuous way, we could actually collect a lot of data and start to observe the phenomena and to understand what was going on in our atmosphere. So let's go now into let's say the problems. I will do the next 2 slides, Ali. This is actually what has happened during the last year. We were in December, launch everything, let's say first image, March 2023. Then we started to do a trial dissemination in November 2023, and then we had the COM anomaly, as you just heard. Basically, we started to have a data interruption, and we were not capable of receiving and operating the FCI anymore. We started to put on the table a lot of scenario. Maybe we can move the COM once a day, maybe once an hour, maybe we cannot move it anymore. So we started to brainstorm. Here it was Ali, myself, Munir, which is in the background and in the audience, and Christoph Streif. We were in a room and started to say, okay, what we can do. And actually, I have to admit, I was the one that was hoping for at least 1 COM movement a day, because at least there we had a black body calibration. But then we started to also to go for the worst case situation, so to work without any calibration source. And we had the idea of using our intercalibration system to calibrate the satellite, and it's something that basically was never done. And thanks to the data collected during the commissioning, we started to simulate the instrument without the calibration, and with the calibration we could intercompare, and Ali will show you all the details about that. And actually we came with a proof of concept that this technique could actually serve as a kind of synthetic black body. Then in May arrived the decision of not operating FCI with the COM. So we said, okay, we go live with this system. And actually it was working. So it was really a big success, because the data could be calibrated, and we restarted the observation with FCI in July. And now we are basically in October, and everything is working fine on the instrument side. So you already know what the COM is. In terms of operation, this is what was happening. The instrument is scanning in this way, and when it's arriving up to the north, it's performing a retrace. And this is when the black body is inserted. So you have the deep space at the edge of each swath that is used to basically to obtain the offset of your calibration chain. Then when it goes up here, performs another deep space measurements, and then goes down, and we insert the black body. And this is when we perform the actual thermal calibration. And this was happening every 10 minutes. So we were having an infrared calibration every 10 minutes. Now try to imagine to go from 144 calibration to 0. This is what was happening. And then we lost also the visible calibration that was happening twice a year when you have the injection of the sun here in the side of the Earth. Basically, the visible DMD filters were inserted in the optical path, and we were staring at the sun through filters, and we were actually performing the visible channels. This is all gone. We don't have anything anymore. And the biggest problem here is that the IR channels, especially the 10, 12, and 13 microchannels, are evolving quite fast in terms of degradation. So we need to calibrate quite often these channels, otherwise we will be out of spec very soon, and you will have in the data a bias of up to 2 Kelvin in a month. So it means that your data will degrade very fast. And this is due to the design of the instrument. Basically, there is a nice layer that is building up on the detector plate, and this is changing the gains of the instruments. With the black body, we could compensate. Without the black body, we had to come with another solution, basically. And this is why we wanted to use MIC-Mix. So this is now the job of Ali, that will explain you all the details of on how we use YASI to intercalibrate and to calibrate FCI.
So good morning, everyone, and thank you, James and Alessandro, for the very interesting introduction and the beautiful slides showcasing FCI images. Now I will shift the focus to the mitigation techniques that we implemented to address this CAM anomaly issue. Alessandro already mentioned the first part, kind of a quick timeline of the FCI journey. And for those of you that are not familiar with this tool, MIG-Mix, it's our in-house multi-mission tool to independently monitor the calibration performance of multiple instruments and those of their onboard calibration. And basically, we use vicarious calibration and intercalibration with other instruments. And so that's a way to transfer the calibration from one reference instrument to another instrument. And the technique that we use here in MIG-Mix, so particularly MIG-Mix is really a beast. So we have so many different processing modules and calibration and intercalibration modules in there. The ones that we are using for this particular task is GeoLeo, so it's the G6 based on G6 algorithm, GeoLeo algorithm. That it's straightforward. So what we do is simply to collect simultaneous nadir collocations, SNOs, between the two instruments. The Leo one, in this case, is IASI, and the Geo one, which is FCI. And so you see here is this laser light. So this is one example. So we look at the collocations between the two instruments, and this is one example of all the collocations for one single day that we see over Africa and also over the ocean. Then we do filtering by angle and time, just to make sure that what the two instruments are seeing actually is from the same geometry, or let's say kind of similar. So this is to just reduce the amount of potential biases that we have between the two. And for this one, we use all the collocations that we have. So it doesn't matter if it's during day, night, all the skies. So ocean, land, cloudy, whatever we can actually get. Once we have the selected collocations, then we convolve IASI, which is the reference instrument here. We convolve the IASI spectrum with the spectral response function of FCI. And for those of you who know IASI, there's a small part there, which is 3.8 channel of FCI. IASI doesn't cover that part, so it doesn't go that far. And for that one, we use a technique called gap filling. So we use simulated IASI data, and we extend that part just to make sure that that part is also covered. And by doing this convolution, there's also very nice that we can actually diagnose if there is any SRF error. That later I will come back to this, particularly for one of the channels that we suspect there might be some issues. So then we have created so far this FCI-like radiance, and then simply we just accumulate collocations over a 30 days period. and apply weighted regression. And then what we have been doing so far in MIGMIX, it was to run a sliding window of 30 days. But for FCI, definitely that's not going to be the case. So the first question was how, let's say, small the time window could be, because we need to actually do this on a daily basis. So we have to go down to a day, or even better, half a day. So that was one of the tests that we did with this one. Finally, we did it with half a day, 1 day, 3 days, and 1 day seems to be a good trade-off between the number of collocations that we get, because it's also important to have enough collocation. Enough collocation. So 1 day seems to be a good trade-off between the number of collocations and the accuracy that we expect. And finally, then we evaluate the uncertainties, and we can actually verify radiometric accuracy requirement, which is 0.7 Kelvin for reference radiance in the thermal channels, and also 0.3 Kelvin for the lifetime stability. One thing that I would like also to mention here is, so you know that we simply transfer the calibration from IASI to FCI. So this is particularly what we do. And here I have to mention that this wouldn't have been possible without the excellent calibration of IASI. So a big thank you to the IASI team to have such a wonderful instrument and a very great, let's say, calibration. And for now, we use both IASI B on METOP B and METOP C. The reason for that is we just want to make sure that we have enough collocations every day. And just if there's really no concern about if they match nicely, because we have already tested that, and they are actually pretty close, so we can put them all in the same basket and just do the calibration. So Alessandro already mentioned about when we faced the common anomaly issue. In response, we developed this the proof of concept, just to explore that if we could recover the blackbody gains. So those gains were generated every 10 minutes by the blackbody, and in the IDPF, so those are 24-hour, let's say, moving average is taken from those ones and applied to the data. But if there's no blackbody, so we don't have that gain. And what we did, we started with using a stable period of 15 days in December. That was a stable period for the IDPF. And this data was already calibrated. So the first step was to decalibrate this data. We did so. We decalibrated and tried to retrieve the blackbody gains. And it was successful. So it was really promising, the results. And after that, we followed this with functional test, just mimicking if the instrument is switched back on, and then we have this data coming, and every day we have to derive these gains from MIGMIX and then push them to the ground facility and just try to mimic the actual scenario. And that was also successful, though in that case we actually noticed that there are some issues with the water vapor channels, and that was later traced to the incorrect nonlinearity corrections. Those have been already fixed. And this was like the functional test. So we started with a gain that was really off here, if you see my pointer. And the next day, MIGMIX actually gave us this gain. And the next day is also, so the black dots that you see are the gains from the black body. So those are every 10 minutes. And what MIGMIX gives us is 1 gain per day. And maybe here's, I need also to explain how this method works. So every morning, we have the collocations collected over the past 24 hours. And then we use MIGMIX to generate what we call as the channel gains. So 1 gain per channel. And these gains are going through a quality check procedure, and that quality check involves also checking, let's say, checking them against NOAA 20 and NOAA 21 CREASE, so the American instrument, just to make sure that we are not really going far off from what we should be at that line. And then next, we use some statistical metrics just to make sure that, okay, this is in, let's say, agreement with what we expect. And after passing this quality check, we have a predictive model. So we fit this gains into the predictive model. And that model actually predicts the gains for the next 5 days. And that's also important because we need this in case of any interruption. We have a gain to ingest. And Apart from that, this predictive model ensures that we are not really, because anyway, the model has some uncertainty, so we don't want to have these jumps. So we make sure that the gains are evolving smoothly. And once we have those, let's say, predictions, and the last step is actually to use the equalization using the PRNU and convert this so-called per channel gains to per pixel gains. And that's done through the equalization. And that's the last step. And then we send these gains to the ground facility, to OPS, and those are ingested. And then we have these synthetically FCI images every day. So this shows one example of, already was mentioned that we are doing this live processing since early June, shortly after the instrument was switched back on. And this is just one example. So at the top you see the FCI minus IAZI both on METOP B and METOP C on the y-axis. And on the x-axis is METOP B and C IAZI, just to show if there is any radiance dependency. Of course, this is brightness temperature. And the red lines actually indicate the user requirement, which is 0.7 Kelvin for these channels. And so, as you see, for all channels, we are well around, let's say, minus plus 0.2 Kelvin. So we consider that really good. But we can also spot this channel, particularly 7.3, it seems to have some issue, which we call it non-linearity issue. So we'll come back on that in a bit. And then the comparison against CREASE. So 2 of the channels are not there, and obviously because CREASE doesn't cover those channels, it's 8.7, which is not completely covered because of the gap we have in CREASE data, plus 3.8. But we have been working on those ones also to use the same technique, the gap filling that I already mentioned, just to cover those gaps and also use them for monitoring these channels. But again, what is interesting and promising, we see more or less the same behavior and the same dispersion of the scatters actually with CREASE for all the channels, and that's a good sign. So here also on the left-hand side, you see the gain evolution. That's for 8.7 channel and for 13.3. So the 13.3 is really like we have a trend, and that's absolutely expected for this channel. But if you see also on the right-hand side, so this is the differences to the latest gain measurements. And we are already, so this covers about more than a month, but we like 2 months, and we are already about 6%, 5% kind of drifting. And if this reaches 8%, it means we need to do the decontamination. So this clearly shows that, okay, within a month, we are already out of scope for the user requirement calibration needed. But so the black dots are what we retrieve from MICMIX. And we have done some comparison against when the black body was on, and it's actually pretty similar. So they are in a very good agreement, and that's also very interesting to use this method. And by the way, this method, we have been using this in MICMIX for quite many years, a few years, I would say. And we have already used that for Severi, for AVHRR, for SLSTR. So the method has been well validated, and we are pretty sure about the performance of this GeoLeo method in MICMIX. And also we have lots of validation against other instruments in G6, in the G6 community. It doesn't work. Can you please just move to the next slide, I think. Yeah. So just, I think, this is to show you what does it mean when we have no gain ingestion versus when we started the gain ingestion. So yeah, here we actually have the very first day that we started to have the live processing with this retrieved gains from MICMIX. The lower part is when we have no gain ingestion, and there is actually when we start from the RC that we started to have this gain ingestion. And to next slide, please. No, one back, and then if you go back one slide, yeah, and then click on that right-hand side figure, please. Like it seems it doesn't work. Up. can I click on that right-hand side figure, the short movie demonstrating the impact? Can you please do it? Yeah, it should be in full screen mode, but anyway. So this is actually, you see the stripes, and immediately the moment that we have the gain ingestion, so if you, the quality of this screen is a lot better than this one. So the stripes and also this is the dust RGB. And for those of you who are familiar, you immediately realize that, okay, these colors are not natural. And once we ingest the gains, then immediately we have this change in the stripes and also the RGB color. This, I think I have 2 more slides. Hopefully that's not running. So for the water vapor channels, I already mentioned about the nonlinearity issue that we have with 7.3 channel. So we noticed this nonlinearity, and simply it's for colder scenes, it seems to be okay, but when we have, let's say, warmer scenes, then we tend to have this small shift. And this is the comparison versus Greece versus Ayazi, and also we have done some comparison versus Severi. So in all cases, we have this kind of non-linearity. So the first question was, is this really because we don't have the black body? So we did some comparison. No, even when we had the black body on, we exactly had the same issue. So this was there since the beginning of the, let's say, instrument. And then the next step was to do some investigations if we can actually find the root cause of this. So we did some correlation with whatever we could. This might cause the issue. And that was actually to try to find any strong correlation between the biases, the large biases that we have for this area, and against geometry, time, air mass factor, and even, so we didn't find any strong correlation between those pairs of, let's say, variables and the biases. And then we also checked 1 week before the decontamination and 1 week after the decontamination. So this is not caused by decontamination or by icing. So I think that's also out of scope for this one. And finally, we started just to play with this, and we started to shift the SRF. So we shifted the SRF by 1 nanometer to the left and to the right and to the left. And surprisingly, at about 17 nanometer shift to the right, then we have almost like a flat line. So it's kind of the nonlinearity issue is resolved. Of course, we all know that this is not really the way that we should do it. So, but at least it was telling us something that maybe either it's the SRF, there is some SRF issue, or it's the nonlinearity correction. And this is something that we have been working on that. We do retrieve the SRF from Ayazi, compare it, and also we are now looking back again into the nonlinearity corrections that hopefully this will be also resolved soon. But anyway, again, the bias that we are talking about here is also about let's say minus plus 0.3 Kelvin. So we are still well within the user requirements. So no concerns in terms of exceeding the threshold that we have there. And last but not least is the visible channels. It was already mentioned that thanks to the, let's say, low degradation of linear IR channels, so they are still considered to be valid. And you actually see another results from MIGMIX. This is from the desert vicarious calibration method. And since the beginning, so it's this method it's understood to provide about 2-3% uncertainty. So as long as it's within 2-3% uncertainty, we consider this as being let's say valid calibration for this instrument. And so for these channels, the radiometric calibration, the in-flight radiometric calibration we are using is from last year autumn, and we believe this will be still valid for some time, but as already Alessandro mentioned, this is going to be a long-term problem for us. So in the end, MIGMIX will also take over the calibration task for this one. So MIGMIX was meant to be a validation tool, but now we are using it as the main let's say, calibration tool. And so maybe you notice something like a drift here is near IR 1.6. This was observed in MICMIX using lunar acquisition, using DCC, deep convective clouds, using desert calibration, and but it recovered somehow. So we don't know exactly what was the reason for this, but it recovered. And now what I can say actually for most of the channels, so for the first channel, let's say the V04, V05, V06, V08, it's really good. So it's very consistent, and we don't really spot any drift. With near IR 2.2 channel, we believe that there's a suspected 5 to 10% negative bias. And we don't use this technique for V09. The results are not valid because it's a water vapor channel and we don't really see the surface. So the results from desert are not valid. But we will be using lunar acquisition and our lunar model to monitor the performance of this. And this is also just that to let you know that in MICMIX we will be using lunar, DCC, and hopefully other methods just to monitor the performance of this these near IR channels. Thank you very much. I think we take the questions at the in the end, or yeah, there's still.
It's the last part of the presentation. So when we lost the calibration bodies, basically, I mean, what MICMIX is doing is to work on the statistics, so on the entire, let's say, on the entire detector plate. But our detector is made of pixels. We have to calibrate each pixel, and we have to keep monitoring each pixel. Otherwise, we will have artifacts in the images. We will have stripes. So this comes as an idea on how we can still perform the equalization of the instrument. And the idea is pretty simple. So if you think to a black body, the black body is simply a flat and homogeneous field in the thermal environment. This is gone. What we have in front of us? We have the Earth. So what we could do actually is to look at the Earth as a calibration source. And what we did, here you have to imagine that the instrument is scanning like this. Well, actually scanning like this. And instead of doing the retrace in the deep space, we commanded the instrument to perform the retrace over the Earth. And then, these are basically the data acquired by the instrument. We can actually identify some homogeneous area over clouds, over water, over deserts, and to use them as basically a natural black body, and to retrieve the equalization of the instrument. And this was the first result of this technique for the 10.5 channel. On the blue, you have the on-ground gain on uniformity as measured. And on the red, you have the ones that we managed to retrieve using this method. So this is a kind of valid alternative to keep monitoring the degradation of each pixels and the behavior of each pixel. So this is also to tell you that we are also still investigating on how to fix and how to come with alternative solutions for the loss of the black body. And this is concluding basically our presentation. The data are now pre-operational. They are being disseminated to all users. We managed to mitigate the loss of the calibration source with a valid alternative, which is MICMIX. Since July 25th, the data are accessible to all the weather services, and since September 25th, it's available to everybody. So if we go if you go to EUMETSAT, to EUMETView, you can actually see the data stream in real time. And I would like to leave you with the latest images, which is the blending of FCI, geocolor, and LI as well. So you see actually the two instruments working together in synergy. So you can actually see the power of the system with LI and FCI together. Thanks.
Thank you. Thank you all. I think we have been a few minutes over time, but I think it was worth it. So I think now we still have, I mean, we are extending a little bit, a few minutes to the break. But I mean, please, if you have any questions, now the experts are all here. So now will be the great time to ask them.
Thank you, Thomas Auguste Isa. First, it's really impressive how you managed to turn an offline system into an operational system, an operational feed for the routine processing with such a high accuracy and degrees of confidence. So congrats to all teams. That's really impressive. My question is twofold, I suppose. The first part is you've shown the benefits of having a reference for the thermal channels in space, so from a satellite to the direct intercalibration. I'd like to hear your comments or your thoughts about such a similar reference in the visible channels. And the second part of the, if we had absolute calibration in space for that. And the second part is your thoughts about the need for onboard calibration once we have an SI traceable or reference satellite data that you can use for operational calibration, or maybe not instead of the onboard, but complementary, or to release the pressure and the requirements on the onboard calibration for every mission. Thanks.
I take the second.
Thank you, Thomas. I think so. As I already mentioned, this was actually possible because of the good calibration and having a reference instrument, IASI. So it could be the same story for the Wisner IR channels. I agree with you, not to replace the onboard calibration. Actually, it's a bit tricky. We have to always be careful about saying if this system, because anyway, we really need for such a huge instrument and those channels to is not only to do this, let's say, gain retrieval. We do have lots of different things, including PRNU, and just to ensure that the instrument is performing as expected, we need the onboard calibration, particularly blackbody and other, let's say, either solar diffuser or the MND that we have in FCI. So definitely having a reference instrument is always a good, let's say, opportunity to try to see the calibration of other instruments. And for now, there's not such an instrument, so TRUS could be the future, I think as you call it, the lab in space, right? Or something like this. Yeah. But for now, particularly, so that I think it will be very interesting for high-resolution satellites and for the satellites that are really like focusing on that part. For EUMETSAT, given the user requirements, doing this vicarious calibration using MICMIX and an ensemble of different methods, we are already meeting the requirements, the user requirements. So the system as is seems to be generating promising results, but it will be always a great opportunity to have very well calibrated instruments in space to see how your instrument is performing compared to those reference instruments.
Go ahead.
Yeah, from what I could tell, you weren't trying to do anything about the variation in thermal IR calibration around the orbital cycle. Is that true or not true?
No, we are not doing anything in the orbital cycle. No, it's basically, yeah. What we do is over the day we accumulate the data. So the diurnal cycle that you see, the variation that you see in the daily gain, it's not really well captured by MICMIX. I mean, it's.
I mean, you could, if you included, onboard parameters like instrument temperature and things like that, because that's what you're getting.
This is what we also try. We went also to check the onboard temperatures. And we started to deal also with the industry to understand how the temperature were correlated to the gain variations. And this is still an open issue because basically it could be related to a non-perfect calibration model. So it's still open as a kind of discussion. But okay. Yes, it's we are working also on that part because we would like to actually to push MICMIX to something that is hourly based and mixed with a model. So yes.
That sounds good.
Any further questions? Well, I think you can always grab the people here still during the break and have a one-to-one discussion, definitely. But thank you for joining, and we'll see maybe next year in the same kind of a session again. All right. Thank you. Thank you. Thank you.
cartoons.
Okay. So, welcome everyone. We hope you grab your lunch, free lunch. So join us. We are Francesco and
I'm Anna-Lena.
And we both work at EUMETSAT. And today we are hosting this event with our guests to talk about career and career for early careers, mainly scientists, and in the meteorological field. We are part of the ECP program in EUMETSAT. So we are the early career employment program. This program has 2 years when we work as juniors. During these 2 years, we have a lot of training and development. We have mentorship to guide us a bit and give us advice on what is the best career path also to take inside the organization. And we have, of course, a lot of the managers that support us in developing our technical skills and also soft skills and how to behave in the EUMETSAT working environment. So I work as a cloud application developer, and I've been with EUMETSAT now for 2 years. And
okay, yeah, thanks. Well, I'm Anna-Lena. I'm a geographer by training and by heart, and I work now as Copernicus Data Service Engineer, also at EUMETSAT. And as an early career professional, I'm very happy today to welcome all of you to our panel discussion with our 3 very great guests. We have Julia Figa from EUMETSAT, Joakim Kugelberg from OHB, and Kate Duffy from ZeusAI. And we also will touch really exciting topics around career development in the meteorological field, working in the different sector of meteorological field, new technologies, and the most essential skills to work on. And with this being said, I would like to hand the word to our guests. If you could shortly introduce yourself, what you're working at, and maybe a bit of your career. Maybe we start with you, Kate.
Sure. Hi, everyone. Good afternoon. My name is Kate Duffy, and I am the co-founder and chief science officer at ZeusAI. My original background was in environmental engineering, and I spent a few years working at a civil and environmental consulting engineering firm. And then I wanted to do something a bit more technical and learn to code, so I went back for my PhD. From there, I went to work at NASA Ames Research Center, where I'd been interning for a few years, building AI tools to work on satellite data. And there, I started working closely with my co-founder at Zeus. And with the support of our manager there at NASA, we applied for small business funding and received that from NASA. And we've been running our company for 2 years. And a big milestone we had this summer was releasing our first model. That's a foundation model for Earth observations with applications in data assimilation and forecasting. Thanks.
My name is Joakim Kugelberg. I'm Swedish. I've been working for 35 years in the business. So I started in Kiruna in the very north of Sweden. Worked there for a while, and then I was hired by EUMETSAT, which was very pleasant because I was quite tired of being in the north of Sweden. So I was with EUMETSAT for some years, and then I was back in Sweden with Smart 1, the lunar sonde. And after that, I went down to Germany again, this time Munich, and worked with FCI, so the imager of the third generation Meteorsat. And then after that, I've come back to Stockholm again, and now I've been project manager for Arctic weather satellite that was just launched this summer.
Okay. Yeah, I'm Julia Figa. You saw me if you were here on the plenary session before. I work at EUMETSAT. My Ausbildung, I've been too long in Germany. My training at university is not as a meteorologist or a physicist. I'm an engineer, but civil engineer, in fact. But towards the end of my career, I had the opportunity to start working with remote sensing to use the data in ocean engineering, and I got really hooked by the whole field of remote sensing, the satellites, and etc. So after a long way around, I ended up with EUMETSAT. I've been working for EUMETSAT now 25 years, but doing many different things, from working in the science department, then with operations of EPS, and now I moved to the more long-term projects of preparing for new programs, and in particular the altimetry programs.
Okay, yeah, thank you very much. I mean, it's nice to have a panel coming from all the different sectors in the meteorological field. We have like an agency, we have the private sector, and also startup. So as a question for the beginning to warm up is, what do you like most about working in your field? What excites you the most? I'd say maybe we go reverse order. So Julia, if you want to start.
In EUMETSAT or in the field in general? Because
maybe both.
Yeah, maybe both, yeah. Of course, I think that this field gives the meteorology and everything that goes around, the space, the applications, etc., gives you the opportunity to get out of your comfort zone and get to the next step. You feel comfortable doing, for example, science, and then there's more to it. There's all the engineering behind. There's all the management, the international relations behind. So there's an opportunity of getting you out of your comfort zone and trying new things. And I think this is what really gives you more reward of working in this field. Yeah.
For me, maybe it's in teamwork. I enjoy very much working in a team with very clear targets, in this case, then a satellite launch, for example, and I can almost enjoy a deadline where things are very late and doesn't work, and then I know from experience that the end, with all the people's good intention and good brains, somehow it always converges at the end and things work, and it's almost enjoyable to see it. But I like a lot when people just work closely together to solve a common task.
Yeah, and I also really enjoy all the smart people I got to work with. But one of my favorite things is the convergence of technology development and new sensing systems that are available. That mean the field is changing really fast, and there are a lot of really interesting problems and opportunities to be creative and push the boundaries of your background, as Julia was saying.
Yeah. And as a follow-up question, maybe we want to ask, can you highlight a bit some differences in the way of working in different fields? So if you change, for example, from NASA to a startup, or from EUMETSAT to a private company, or even inside the EUMETSAT across different teams, what are the main highlights for you? If you want to start, Kate, maybe.
Sure. So working at the startup actually has a pretty similar feel, I'd say, to being a research scientist at NASA. We're mainly doing kind of curiosity-driven basic science, and we're still guided by the scientific priorities that NASA and the Department of Energy and other government organizations are defining, since we respond to calls for proposals. But I'd say a difference is that we are a bit more of a fast-paced environment, and it's very collaborative since we have this common goal of a successful company. Whereas I think that publications and grants, there's one first author and there's one PI, so it's a bit more individual. And then, of course, the main difference, which could be a pro or con depending on the day, I think, is that there's a lot more responsibility in a small organization. You have to wear many hats and learn many new things all the time.
Yeah, I can start with saying that I enjoyed working in EUMETSAT a lot, but I also quite critical to these agencies, how they work and how there's the castle building, and I think profitability and in a private company also cleans out certain structures that doesn't clean out themselves. So.
Okay, I've done most of my career at EUMETSAT, so for me, what has changed when I was changing jobs within I think that what changes internally at EUMETSAT when you move from one job to the other is that your internal customer also changes. But at the end of the day, you need to realize that even if your internal customer is who needs you within the organization, who needs your output, it's different. At the end of the day, the final customer of EUMETSAT is the users, and this is what you need to keep your head on and your goal really clear, even if your role is changing. Another thing that I found that changed with me a lot is the way you take decisions. If you're working in operations, your decisions or your priorities are very driven by what's going on with the satellites, with the data that needs to go out, and it's a very it's a complex stressing sometimes, but with a very clear decision-making process and priorities. Yeah. If you work in projects and you must have fast-paced projects, like when we're putting together the altimetry ground segment, that is really, the launch is there and it's not moving, and you really need to make it, and you need to make decisions. Almost always better to take a decision than not to take it. And now I'm back into much more long-term work, looking into future programs, what we need for the future, and then the decision making. It's almost always better to wait with the decision until you have all the information, because the impact is very long-term as well. So I would say the decision making is really changing from your context, and that's quite a significant thing that you need to adapt. Yeah.
Okay, that's really interesting. Maybe just to follow up on this decision making, because I find it quite interesting. How do you feel about that, Joakim, in your current job?
Yes, decision making is very, of course, critical. If you develop a system like a satellite, I mean, you can lose a lot of time if you hesitate. So, but it's of course not one person that makes a decision. It's the whole. As I started saying, the whole team needs to work and interact properly in order to find the right way all the time. So it's like an organism almost, which is also the thing I started off saying, that I like a lot to see the team working as one entity and going ahead. But decision making, you cannot wait.
Yeah, I guess. As long as it all comes together in the end. Well, the next question is a bit of the challenges you've faced in your career. So, I mean, life is full of ups and downs, and so I guess careers are as well. So, I don't know if one of you would like to share a challenge in the career, and what you took from it, how you resolved it, what was your learning from it. Maybe Kate?
Sure. So one challenging event that we've had in the last year at the startup was deciding to make a pretty major technical pivot from a kind of tried and true model we'd been running to a more untested idea. The first project being emulating an existing numerical weather model. But we decided to try to build something instead from scratch that was based only on data-driven methods and observations. So there's no kind of existing numerical simulations coming in at all. And so that was kind of a newer idea, and it involved having to switch because we have a relatively limited resources as a small company. We just have the computing access that we have and the number of staff we have. So we had to give up any commercial traction we had with that first model and start to develop our next model. So that was a big decision, and I think we just had to be willing to take that risk and be adaptable.
Yeah, thank you. Just if you like to share anything.
Maybe
continue.
say that I'm a naval architect by education, and I was hired there in the north of Sweden in a satellite control team there as the leader of that team. And the satellite was launched, and almost the whole engineering team had left after launch because they didn't want to work with operations. But so I found myself very lonely there, without much knowledge. And there I found one person that was very knowledgeable, and I really got very close to him and sat very close to him for 6 months and tried to understand, because then he also left. So it was a very challenging start to my career, but it was also very, very rewarding to finally find myself in a role where I could feel comfortable with taking this huge responsibility with your stationary communication satellite that I've never seen. But it was a challenge.
So mentorship is mentorship or help of senior co-workers is really very important, I think. So I think it's great that you're doing this. Challenge, I think the challenges mostly come, many types of challenges, but if I can think about a couple, of course, at EUMETSAT, when we put together for the first time the EPS program, that was really a major challenge. I mean, if you remember at least the early days of that, even you were working on the geo, but this was for us, you know, as an organization, the first time we were doing that. Huge ramp up of teams that we all had to speak the same language and then really get you know, rowing it all in the same direction. So that was a huge challenge, and I feel really proud of having been part of that. I think that these days, to me, most challenges come from elements or factors that you cannot control. You know, in developing programs, the politics of it, the discussions with actors where you need to get to agreements because you cannot control, and that's fine. This is all about reaching consensus, and that's a huge challenge sometimes, but I think it's really rewarding when you get through the door and you achieve the common goal. So.
Yeah, so challenging also brings a learning part. So what do you do to keep up, basically, with the technology trends? So to keep evolving and learning in your role in order to get better and more prepared for the next challenge or for a similar challenge, so that you are already prepared. Joakim, if you want to start.
Yeah, I don't have time. I think I learn by the job and then the challenges I get through the projects most.
Okay.
Then, of course, I read on the internet like everybody else on what's happening in the business. But I'm not sitting with large books.
Now there is ChatGPT.
The many ways of learning, it's not always about the books. Yes.
What about you, Kate?
Yeah, nothing too groundbreaking on this. I'd say just attending conferences, keeping up with literature, and recent publications is how I try to stay on top of things.
I think it's quite important to always, particularly in a challenging situation, to of course, learn from your mistakes and always try to be aware of the context. Because within the context that you are at the end, you are finding all the tools, all the help, all the what you need to resolve a particular situation. So I think being very aware of the context or what the roles are of everybody that is expected to help you in taking that next step is really fundamental. So know the room, understand the room and the context, where the boundaries are, the actors are. Yeah, so.
Yeah, I mean, now we talked about challenges and how to keep up, and lots of you mentioned lots of practical skills like taking fast decisions, taking slow decisions, rely on teams or doing teamwork and so on. So from the soft skill part, what would you say? What are the most essential skills, or the skills that have helped you so far the most in your career? Me? Whoever wants to start.
I can do that.
Yeah.
I think that something that I personally regret I didn't do more when I was much younger in my career is to be more curious, to ask more questions, and to listen to the answers. Often when you start, you don't really have a long, sometimes you do, I didn't have a long path of where you're going, but I think this doesn't come by inspiration. This comes by asking questions where you don't understand, or when you want to find out. Be curious about what's outside your comfort zone, and listen to that questions, to those answers, and keep crawling through that. That takes you outside where you are and forward. So I think that's what I would. That's what I regret I didn't do more when I was younger. I really recommend that everybody starting their career should really consider that. Yeah.
I mean, I guess that's also a really important thing to do to ensure that you're learning the whole time. Just being curious, asking questions. Yeah. So what has it been for you, Joakim? Like an essential skill?
Yeah, I mean, when you delegate a task to somebody, you of course want it to be solved and reported back to you. And I think an important skill for the person getting the task is networking in a company, and maybe not in a small company like yours, but if in a large company, there's an enormous amount of knowledge. And networking and understanding who knows what and having an open attitude. Of course, it builds on that there is an open attitude in the company. But if there is that open attitude, then I think networking is very important, because then you know who to approach and you can solve a problem when you maybe not yourself have the skill. And then that also brings the organization more and more competence in that way. So I think it's very important, internal networking in the company.
Okay, thanks. So we have been curious, networking, and what has it been for you so far?
Yeah, I'm going to echo the networking. I think it's really important to find good mentors, and that's something that's been really transformative of my experience when I've had a good mentor, whether that was in the PhD program or in my job at NASA. In particular, my manager there was a really distinguished scientist, Rama Namani, and being able to have a scientific discussion with him every week and just talk about my projects and goings-on in the field and in science was really helpful, and I learned so much from him. So yeah, it can feel a little uncomfortable to seek those people out, but I think it's definitely worth it and really rewarding.
Okay, so to conclude, being curious. Networking. Thank you, and
Team
also
building,
through
team spirit as well.
and also finding a mentor and team spirit.
Yeah, from the technical point of view instead, what do you think are the new technical skills that especially the new scientists or you young engineers should develop the most today, and in order to be successful also in our field, the meteorological field or in the space field? Yeah, Kate.
Sure. So I'm of course going to say machine learning. I think in particular foundation models in machine learning are going to be really transformative in the future. And I think that multimodal models will be able to replace a lot of the kinds of single-purpose models that we have, both for processing remote sensing data, and I think they'll make a big impact in weather. So yeah, especially for data assimilation, which is the big bottleneck in weather prediction. And along with that, I think just having good software engineering and technical skills is really important if you want this kind of role.
I don't know what to say really, but mathematicians are also always highly sought after. So I mean, people who can provide numbers are very important when you try to build something. So I think understanding the tools that they use, the MATLAB tools or whatever tools they use, and then master those and the maths behind it, so that they can give you numbers.
Yeah, I think that these days we have more and more data, even if we ask for more and more data, but there's a lot of data outside. I think that it's extremely important to have the tools and the skills, as one of you said, the mathematics skills, to be able to extract information in an efficient way from the data. So this is extremely important. I think you mentioned it as well, Kate. But I think the skills of really understanding that information and making the step of, once you have extracted that in an efficient way, really giving it some meaning into our daily lives and understanding the processes around climate, weather, some of them, and not only. So that more typical physicist or geography skills, all these are really important to make sense of all that data that comes out of these satellites and these ground networks as well. So then let's not lose that skill either. Both of them are necessary.
Yeah, I mean, I guess the technical aspects will always evolve. So bringing back, the skill of being curious and learning on the job as well. Yeah, so I mean, I had another question prepared. How important is networking? You said already, Joakim, that it's the most essential skill to have, or a really important part. But yeah, maybe we could reflect a bit more on this. Maybe also what you, Julia, and Kate think about it, or how to go about it, because we have like all the different tools today. We have LinkedIn, we have the conference app, we have everything, we have emails, we have smartphones. How do you go about networking these days?
I didn't grow up with social media, so I must say I don't make huge use of that. Call me old-fashioned. It's a bit overwhelming sometimes. Participating in events like this, I think is the best way. Not just listening to presentations, but taking the opportunity during the social events to ask the questions that you didn't dare to ask to the speaker, for example. This establishes connections that you can pull from later on, I think.
Yeah, I agree, absolutely. And also I think if you're working on a problem and there's some scientists you want to work with and you have something very specific about their work that you're interested in, they'll probably be happy to hear from you. And that's a good way to get collaboration started as well.
Mm-hmm.
I'm a bit more basic maybe, but your lunch habits, for example, is important, that you change your lunch partners and you interact with people in different disciplines and different projects and try to understand who is doing what in what project. And then it's very important then if you get a problem that you have an idea of where to go and seek information. And I have a discussion with somebody who has had similar problems, and you can feel very lonesome when you don't have anybody to go to. In that sense, it helps a lot in an organization to come to know as many people as possible and what they're doing and what problems they fight.
Yeah, that's actually a very good point to also include networking in the normal day-to-day work through changing lunch partners, being part of initiatives or groups like Women in Aerospace, etc.
So maybe we want to start opening a bit the stage. So now you have the opportunity to ask questions to our guests. The one question that you never ask, maybe. So. Is there any question? Yeah. Do we have microphone?
Hi. This may be question to everybody. Anybody can answer this. You are being a CEO, a CSO, or whatever it is. Do you think working 40 hours in a week will make you a successful company or successful CEO? Or if do you have any tips for us? I meant, I want to be a billionaire. At the same time, I want to maintain my work-life balance.
Very important.
Yeah, I guess that kind of reminds me of some discussion I heard at a conference recently. I was in one session where a successful entrepreneur was saying that her workday doesn't look like everyone's, and she's a mother and has a chronic illness, but that she still makes it work, and that was very encouraging. And then I went to a session later, and this guy was saying, like, now I'm a billionaire, but I did it by working 60 hours a week, and you have to do that too. So I think there are a lot of different ways that people succeed, and like for me, I know work-life balance is really important, and I do my best work when I'm not burned out. So that's what matters to me. What do you guys think?
Yeah.
It's a difficult question. I think you go, it's difficult to say. You go through different phases, I think, in your career where you actually need to put the time into it in a proportional way to your ambition. There are many ways to getting from point A to point B. You can get directly very quickly. You can make a lot of turns. Depends on the path you take. You will need to put a lot of hours and a lot of yourself into this. But it's absolutely respectable to take the long way, make it compatible with your life balance, and keep all that the personal essence of yourself that may not be like essential to get you quickly from A to B, but it will contribute along on the way as well. So, it's a different answer. Depends on where you are in your career. I don't know if this helps.
I would say something similar.
Yeah.
I think if one could look at my time sheet, one could see when I started coming there at 6 o'clock in the morning, then that's period there's a lot of things to do because it's 2 hours before meetings and stuff starts. Those are very critical. But then other times when it's not so busy, then I would not be there at 6. But
No.
I think it would be very obvious from my timesheets when the project has been like under pressure.
Yeah.
But then you need to put hours in. You need to sit quietly sometimes.
Okay, thank you very much. Do we have some more questions from the audience?
Well, thank you all. Very nice discussion. I was wondering, it's, I guess, quite a simple question, but still I'm interested in it. So what for you is the main motivation that you go to work with? So yeah, what keeps you motivated for the job, and what are the, in the length of that, like the things, the dot on the horizon that you still want to achieve? What are your goals still in your further career that you have?
For me, again, it's the interaction with people that is the most satisfying with going to work. But then, I mean, I worked with meteorological satellites for half of my career, more or less, and I also like the end goal of producing meteorological data to a vast community of users. And I think that is, for me, highly motivating. That I would be less motivated by working with a missile system or something.
Thank you. What is it for you, Julia?
For me, I mean, in general, I agree with Joakim. More in a day-to-day, for me, is getting things done. So getting things done gives me alone with colleagues, solving problems is what really keeps my head going, and getting things done is what gets me up in the morning and makes me go to EUMETSAT and make it happen every day.
Thank you. What about you, Kate?
I think for me on a daily basis, it's just that I find the problems we're working on really interesting, and I'm just excited to wake up and go talk to my colleagues and check what my models have trained to do overnight. So I find that kind of thing really interesting. And then in the longer term, I've always been really interested in doing something that impacts climate change. So I'm really excited about creating weather forecasts that could help with integrating different kinds of renewable energy into the grid. So that's kind of like a bigger motivation.
Okay, thank you. Any more questions? There are more.
Since we had the word climate change, I would like to ask a question for some business ideas. You have met many clients, so many stakeholders and many clients. And we have been discussing in this conference mostly early warning systems and monitoring and these stuffs. What do you think the clients and stakeholders are expecting in case of sustainability, adapting, mitigating climate change? What kind of outcomes they require in terms of implementing any measures to achieve sustainability to face climate change?
In terms of tools or in general, I think it's very important to help the stakeholders with a consistent story. So consistent story about the climate, that really helps them go to their own stakeholders and convince them that this is important, this is something that we need to pay attention, that this is something that we need to act now. So consistent data, I'm talking from the point of view of data provider, of course, there may be other points of view, but consistent data and a consistent story that makes sense, it's what for me is the most important thing that we need to provide. But I don't know if from the private sector you have another different view on this.
Yeah, I think consistency and reliability are paramount. And I'd also add something that I think we can deliver to our stakeholders is getting the data faster, and by using a machine learning model that can run in minutes compared to the hours of some more traditional methods.
Then maybe to add that in our business we also have to encourage all these space debris mitigation activities. Absolutely. To see that we're not creating another mess in space. I'm very positive to all these space debris mitigation efforts that are taken, but it's very difficult. I mean, the system we are building, for example, is not completely clean in that respect. It will drive the industry a lot, but I think it's necessary.
To make sure that we put something in Spain, we take it away afterwards. Yes. Yeah. Same as when you go to the beach. You eat, but you take away your stuff and leave it clean when you leave. It's a very big challenge. It's a very important point. I agree.
Yes.
Yeah. Okay. More questions? Oh yeah, I also see some hands there in the back.
Yeah, thank you. Yeah, I can ask another question. We already shortly covered it, like the learning from the mistakes part, which I found quite interesting because, well, being a scientist and, well, also especially perhaps being an early career scientist is like, for a large part, is, failing and learning from these mistakes and, getting better because of that. So I was interested if you have one, clear example in mind that you could say, that went wrong. That is what I learned from it, and that's how I came out better on the other side. If you have any clear example.
It is in the wrong business if you are sending up satellites and they fail. But of course, I have no real example, but building satellites is all about testing and qualifying on ground and ensuring that it works. So of course you learn by every failure on ground tests, and you improve your confidence in the design or in the manufacturing. But the test program is of course essential to space activities.
And there's some times where you can cut corners, and sometimes you can't cut corners. So I think identifying in which scenario you are is really very key for your survival in general, I think.
So Julia, how did you learn which corners to cut or not? Did you learn it the hard way, or?
No, when you work in operations, you learn very quickly. There are some corners that you cannot do. I mean, when you make mistakes. But when we were, of course, starting with the operations of EPS, I was working with the scatterometer team, maintaining the processor of the scatterometer, running, providing data, and you have some processes to test safely an improvement or an extension. And the day that you say, oh, come on, this never fails, that's the one that is going to fail. So there are some processes established to help you not make mistakes. So make use of them, because that it comes from lessons learned, not from you, but from many people that make those mistakes before. But of course, be ready to accept that you always are going to make your own mistakes, and this is fine too.
Yeah, I think this is also where maybe mentors can come in and help with that learning process. How about you, Kate?
Since I don't work in operations, I'm free to fail a lot with relatively low consequences. So I don't think I've ever had any project I've done that hasn't had a lot of failures along the way. And I think the important thing is just to understand why they happened and put them on your list of things not to do again. So you can fail in new ways next time and learn something new.
That famous lessons learned Outlook page or OneNote page. Okay, I think we had one more.
Another one?
Question. Yeah.
By Domenica.
So I have a question. What tips would you have for young early career scientists, engineers, to make managers to be able to entrust those young people with new responsibilities? What the things that the young person should do well, except for, of course, organically gaining experience, getting knowledge, and then, well, my experience is that things don't happen necessarily organically. So what tips would you have for that, to just for the career to progress?
I would say showing that you can take responsibility and that you can deliver on a task given. It's as simple as that. I mean, as a project manager or a team leader, you're always looking for people who can take a task, take responsibility for it, and deliver it in time, in a proper way, in a clean way. That's of course what you're always looking for in terms of giving people more and more responsibility.
Be accountable for what you do. I think accountability is very important. And also I think that in order to get more responsibilities, doesn't always happen organically. It's true that in some organizations there's a structure organized and with clear roles, and it's not always to break that. I think that always show if you give a how to call it a clear picture to your manager about what you can do, but what you cannot do as well, and be honest about that. I think this is a good starting point for trust. But sometimes you will find yourself in a situation perhaps where you realize that you're not going to get responsibility, but if you don't, something's going to go wrong in the project, so don't be afraid of saying it. Perhaps that's when you get the task. You may not be happy with the task, but you can say, okay, there's something missing. Everybody has blind spots. Your managers will have blind spots as well. We all do. So keeping an eye open and finding the blind spots is always a good way of showing that you care, showing that you can look beyond your work, and then creating an opportunity, perhaps.
Yeah, I think that's all great advice. And I also try to just be a good communicator when someone delegates something to me. So if there's something I'm unsure about or that's taking longer than expected, then that's all known to the whole team, and then nobody has any questions.
Okay, thank you.
We still have time maybe for one more question. Or we can ask maybe...
There was a question in the back.
Okay, so I maybe have a different question. So I've been looking to the vacancies of EUMETSAT, and there are a lot of high-level jobs vacant. But like for early scientists, what's the best way to get into, for example, EUMETSAT or another company? Like, is there an initiative application advised, or have you got tips for that?
That is a very good question.
This question for you guys.
I think
excellent.
we can take that.
Yeah.
So at EUMETSAT there is this early career employment program, ECEP, and the positions for that are for both like junior engineers and junior scientists, and then in different departments across the organization. And the recruitment process is happening once a year. So all the vacancies for this early career employment program will be published, I think, later this year, towards the end of the year. And then you will find above or next to all the higher level or more experienced level positions also hopefully a couple of early career employment program positions. So you can just keep an eye on that, or if you have more questions, feel also free to approach me and Francesco.
And don't be scared to apply, because I mean the junior is either going out directly from the master, but also if you have a bit of experience already, you can still try to apply, and the program is working very nice. At least we have been very happy. So if you have more questions, just come after and we can tell you more.
Okay. My strategy was to go to an obscure place where there was no competition.
That's a good one too. No, I think that also working in EUMETSAT, there are opportunities, I believe. I don't work for HR, but I think there's also a program for internships. So if you are, were you part of that too before?
Yes, yeah. I was
so
also
if you
doing
don't, I'm not sure whether you were going to like or not EUMETSAT, you may want to come for a few months and really try it out first. And decide whether you want to apply to any of those jobs.
That's how I did it, and now I'm sitting here.
Exactly, and then she decided that she liked it, and then the opportunity came up with the career jobs. But you need to wait for that. Of course, their internships are also announced through the website in the same webpage. So it comes, I think, twice a year or something like that. But
yeah, that's also a very good point. All right, then I think we've come to the end of the discussion. First of all, thanks to all of you for being here and listening and contributing your questions. Keep an eye out for the vacancies at EUMETSAT in case you found this talk now inspiring and want to pursue a meteorological career, maybe at EUMETSAT. And yeah, thanks also to the three of you. It was a pleasure to have you here. And yeah, I hope to see all of you around and have a nice rest of the conference. Thank you very much.
Thank you.